In addition to having tags and having information inside those tags, XML can also have comments. And comments are just that. They're ignored by the parser being the computer code that's going to read and understand the XML. They're just ignored. You can tell a comment because it starts with an angle bracket, exclamation point, dash, dash, and then it has the actual body of the comment, and then it ends with a dash, dash, closing angle bracket. It's kind of an oddball thing, and that's just the way XML is. One caveat to comments: they can't contain two hyphens in a row as part of the comment itself, because that starts off the ending tag for it. So you can't actually have two dashes inside of a comment. Now, comments can go pretty much anywhere in XML. The only thing they can't go inside of is inside of a tag itself. Now, I don't mean between an opening and a closing tag. I mean actually inside of an opening tag or inside of a closing tag. But other than that, comments can go pretty much anywhere. They're there to aid in human understanding of the information that's seen, but computers just ignore them, just like they would ignore comment in computer code. So those are XML comments. Here's a quick look again at the example XML we saw a couple slides back, and here we've just added a couple comments. One comment just says, this is a valid comment. The other one says, this is also a valid comment. Now, one thing you may notice at this point is that the comments are a different color. And while XML is just plain old text, if you do your XML in a dedicated XML editor, editors will usually color code the XML so the different things are in different colors and everything makes sense. In this case, the editor I use makes the tags dark blue, makes comments green, makes the actual data black. You'll see other examples in more examples of XML. It's also important to note that editors will let you decide which colors you want to use. In this case, I pretty much stuck with my editor's defaults, although I did change a couple of things to make it a little more visible on a light blue background. So you could make it whatever color you wanted, whatever worked for you. The XML declaration is something that goes at the beginning of each and every XML file. And it's a declaration that this is indeed XML and not just a bunch of text that just happens to look like XML. Inside that XML declaration, you can specify which version of XML you're using, generally 1.0. As far as I know, that's the only version there is right now, and as well as the textual encoding. And again, your editor may just add this in automatically, or you could change the encoding as well. UTF-8 is a common choice there. But that's a declaration that this is indeed an XML document, and that a parser reading this document should expect to be able to make understandable sense of it in terms of the rules of XML. Now, XML processing instructions are a little bit of an oddball, and you're not going to see them a whole lot. In terms of where they'll sit in an XML document, they come right after the declaration, but before the actual XML starts happening. So in our example we've been using, they'd be right after that XML declaration, but right before that person tag starts off. Now, they're used to encode application-specific data. What does that mean? It means whatever you need for your application. Is really what that means. Most popular usage is to associate presentation or transformation files along with the data. So there's an example here at the bottom of the slide. Here's an XML style sheet processing instruction that says, hey, use this style sheet called mystyle.css, and depending on what you were using to read that XML document, it might then go pull mystyle.css, use the styling instructions in there to make the XML look pretty. But that's not the only thing you could do with it. I mean, you can really put kind of anything you want in there that then later gets passed to an application that's doing something with the XML. But again, it's not something you see a whole lot of. It's also weird looking in that it starts with an angle bracket and a question mark, and it ends with a question mark and an angle bracket. So it doesn't look exactly like a declaration, it doesn't look like a comment, and it doesn't look like a normal XML tag either. It's just kind of an oddball. Now, up until now, we've been talking about different kinds of things, objects in XML. We've looked at some elements and talked about their tag names. We've looked at the declaration and at processing instructions and at comments. Now we're going to talk about XML attributes, which aren't a standalone thing. They are part of an element, are part of a tag. So I have a tag, and the attributes go inside. Remember how earlier I said comments couldn't go inside of a tag itself? Well, attributes do. Attributes go inside of that opening tag. They're actually a part of the element that provides more information about that element. And they work as a name-value pair. So you have a name, and then you have equals some value. Those values are limited to a string. In other words, you can't put tags in there. You can just put a string, whatever string you want, but it's just limited to a string. They're not as flexible as elements, but they're simple to use too, so they've got advantages as well. Let's take a look at one. Here is our XML example, only this time with an attribute added, and you'll see the attribute there inside the opening person given name tag. In this case, the name of the attribute is language code, and the value for it is ENG. And you'll see that in my editor, language code gets colored, or attribute names, in this case language code, get colored a dark red, and the values for those attributes are basically a dark orange. So you'll see it there. And again, you can have attributes inside of any of the tags. There could be one inside a person name, there could be one inside a person, but they go inside the opening tag itself and provide additional information. In this case, the additional information is, hey, this person given name, that's Tom, it's in the language ENG, which in this case would stand for English. So if it were my wife, it would be something different. It would be language code NOR for Norwegian, whatever the particular language code happens to be. Now you'll notice in that previous example that the ENG was surrounded by quote marks, and that's a requirement for the values of attributes. Attribute values must always be enclosed in quotes. Now you can use single quotes or you can use double quotes. Usually you'll see double quotes, they're the most common. But the key is you have to be consistent with each attribute. You can't start the attribute value with a single quote and end it with a double quote. Those have to match. And if the value itself contains single quotes, then you need to use double quotes. Otherwise, your parser would think, hey, that's the end of the attribute value. And of course, vice versa. If you've got a double quote in there, you need to have single quotes surrounding the attribute value. But the bottom line here, they need to be surrounded by quote marks. All attribute values need to be surrounded by quote marks, and typically you'll see double quotes as the most commonly used. So here's an example of a single quote inside an attribute value, that value then being surrounded by double quotes. And in this case, we've added another element to our example. It's called a person name augmentation. And if you're wondering what that is, that's a NIEM thing, and we'll be dealing with that far, far later in the materials. So for right now, just accept there's a tag called person name augmentation. And inside of there, we put a person name category code. And you'll see that just like the tag names, you can use camel casing to kind of break apart attribute names into different words. Now you might notice that the tag names all started with a capital letter, and the attribute names are starting with a lowercase letter in some cases. For this person name category code, it's lowercase in any case. But the reason for that is that's a NIEM convention, and I grabbed this example out of the NIEM. So this isn't an XML rule. You can do it either way. You can put it all caps if you want as far as XML is concerned, but just for this example. But the important thing here is to see that person name category code has a value that is a category for Tom's name, because I couldn't think up one. But the important thing is, because it's Tom's name possessive with a single quote in there, technically not an ampersand but an apostrophe, but we'll call it a single quote, we need to put double quotes around the whole value. We couldn't have used single quotes in this case. So that's what we're showing here, is you can have a single quote inside the value if it's surrounded by double quotes, and you could have a double quote inside the value if the whole value were surrounded by single quotes. So when you're doing XML, when should you use attributes, and when should you have tags nested inside of other tags? Well, if you're talking about the NIEM, the answer is hardly ever. The NIEM itself hardly ever uses attributes. It uses it in a very small number of cases, and for the most part, the NIEM does everything in tags. Historically, attributes have been for metadata, which is data about data. Think back to the previous example with the language code. The language code was about the data. It wasn't additional data really about the name, the given name as a given name conceptually, the concept of a given name. Rather, it was information about the actual chunk of data, the TOM, the TOM, saying what language that's from. But ultimately, it ends up being a subjective decision. If things seem like data, you do an element. You use tags for that. If it seems like a description of data, you use an attribute for that. But I'll warn you, subjectively, this stuff can get people really, really ticked off. I've seen people get red in the face and pound tables at each other over whether something should be an element or an attribute. So one of the nice things about the NIEM is, since the NIEM hardly ever uses attributes, those kind of issues hardly ever arise. But in a general purpose XML environment, you'll probably use attributes more frequently than you would doing NIEM development. Now, there are other considerations when determining whether you want something to be an attribute versus an element. One of them is, what can they contain? Now, we talked earlier about an attribute being just a string. An element, on the other hand, with tags around it, that can be any data type. Now, at this point, we haven't talked much about data types, and that really gets more into the XML schema side of things. But once you get XML schema involved, you can start to say things like this element needs to be a string, needs to be an integer, needs to be a positive integer, needs to be a non-negative integer, needs to be a date in a certain format. So you can do that kind of stuff, saying what elements can contain. Meanwhile, an attribute is just a string. The most you can do with it is restrict it to a list of particular strings, and that's, for example, a code table. So, I can say the string has to be male or female, but beyond that, it's just a string. Of course, the other advantage to elements is that elements can have other elements nested inside of it, and the element can have attributes of its own. So you've got an element, and it can have attributes. It can have more elements inside of it, in addition to or instead of the actual data. An attribute, meanwhile, can't have any of that. All an attribute can have inside is a string. That's all it can have. That's all it'll ever be able to have. So now it's time for an exercise. And this exercise is called attribute or element. The idea is we have 5 different items here, and you need to determine which of these should be attributes and which should be elements. And, not just randomly, you need to think about why as well. The items are name, measurement units, like length or whatever, age, reliability, and accuracy. So the idea now is that you pause the video. You don't just keep playing the video and see the solutions. Instead, you want to pause the video and actually think about this for a minute. Remember, if you don't pause the video, you're only cheating yourself, and you're spending a decent amount of time watching this. So don't cheat yourself. Pause the video and think about these before going on to the solutions. So here we go with the solutions. Now, I hope you paused and thought about these before moving on. Okay, assuming that you have, let's look at some proposed solutions for these. Now, the concept of a name, that's usually element territory. A name can be represented in a lot of different ways. We could be talking about just a string. We could have had in those previous XML examples, person name, and then the whole string Tom Carlson, my name, and then the end of person name. And that would represent the full name like that. Or we could structure it, which is partially what the example does. It has person name, and inside of there is person given name, and then that holds the value Tom. And then you could have a person middle name and a person surname, and you could break it apart. And you can't do that kind of stuff with an attribute. That's element territory. So that one's an element. Measurement units are usually an attribute because they're a quantifier. Well, you have a quantifier. Now, they are a quantifier. They quantify exactly how you're measuring things. Now, the example on this slide is speed. You've got the concept of speed, and I'm going 100. And what does that mean? Am I going 100 miles per hour? I don't know. 100 meters per hour? I don't know. 100 kilometers per hour? I don't know. The knowing I'm going 100 is kind of meaningless without having the measurement unit. The measurement unit is information about that value of 100, and so it's an attribute. Now let's look at age. Age is something you'd want to have be an element. You've got the need to maybe extend it from something like just a simple age to a range, because you don't always know the discrete exact age, so you might want a range. But you also need to qualify it with a measurement unit sometimes, which we just saw in the previous solution. For example, I'm 46. Okay, now if I say I'm 46, particularly if you're seeing me at the same time, you're going, oh, okay, Tom's 46 years. It's unlikely I'm going to be 46 months because I sound hopefully older than a 4-year-old, and certainly not 46 days. But you don't really know that without having some measurement unit attached to it. And again, you can't do that with attributes. You can't put an attribute on an attribute. You can only put attributes on elements, so age would need to be an element. Reliability and accuracy are both attribute sorts of things. Reliability typically qualifies something else, like in the judicial world, a statement of fact, but just, in any world. If I said the reliability is 90%, your first question is going to be the reliability of what? Reliability as a concept doesn't hang on its own. It's something that's applied to something else. And that means it needs to be an attribute. It's an attribute that provides information about the chunk of data that's going to be surrounded by a certain set of tags. Same with accuracy. Again, it typically qualifies something else, like a measurement of something. I was going 20 miles an hour plus or minus 5 miles an hour. So again, it's something that qualifies something else. It's not a standalone thing. Well, what's the accuracy today? Well, it's plus or minus 5. It doesn't make any sense unless it's applied attached to something else. So again, that's a perfect role for an attribute.